You have never seen a black hole directly, not the way you see a planet or a star. And yet, we can count them, we can weigh them, we can even hear them collide from billions of light years away. So here's the real mystery. How do you discover something that's designed to hide? Because black holes don't just sit in space like monsters in the dark. They act like the universe's invisible ledger, balancing galaxies, rewriting star systems, and sometimes erasing entire suns like they were never there. And before we jump in, if you love deep space stories that feel like mysteries you can solve, hit subscribe and join us on Fragile Universe. In today's episode, we are going to tell you about the story of black holes, what they are, how we discover and count them, the most verified facts we know today, and the surprising role black holes play in shaping the universe. So, what is black hole? A black hole is a region of space where gravity is so intense that nothing, not even light, can escape once it crosses a boundary called the event horizon. That event horizon isn't a surface like a planet. It is more like a point of no return in space-time. Black holes aren't vacuum cleaners. If our sun magically turned into a black hole with the same mass, Earth wouldn't get sucked in. Earth would keep orbiting, because gravity at a distance depends on mass, not on whether that mass is a star or a black hole. So why do black holes feel so extreme? Because of density and compactness. A black hole packs a huge amount of mass into a tiny region. So if you get close, gravity rises brutally fast. Now, black holes come in main weight classes. Stellar mass black holes, formed when massive stars collapse. Supermassive black holes, millions to billions of solar masses sitting in galaxy centers. NASA notes that most Milky Way-sized galaxies have them, including ours. Sagittarius, a star, at about 4 million suns. Intermediate mass black holes, the missing middle, likely formed through mergers and dense star cluster processes, still a major research frontier. So black holes are real. The physics is solid. But that leads to the next problem. If you can't see them, how do you know they're there at all? We didn't discover black holes by seeing them. We discovered them by collecting receipts. Receipts are evidences that only a black hole can explain. Receipt number 1. Light from the fall. Black holes are dark, but the matter falling into them is not. In binary systems, gas can spiral toward the black hole, heat up, and blast out X-rays. That's why NASA says binaries have revealed around approximately 50 suspected or confirmed stellar mass black holes in the Milky Way, even though we estimate there could be tens of millions to approximately 100 million in our galaxy. That gap is wild. We think the Milky Way may contain 100 million black holes, but we've identified fewer than 100 stellar mass black holes directly. So most black holes are basically silent. No bright disk, no fireworks, which brings us to receipt number 2. That is, motion without a visible mass. Sometimes you see a star moving like it's attached to something, but there's nothing there. That's how we find black holes, through orbital motion and astrometry, tracking a star's wobble. NASA's Hubble even reported direct evidence for a lone black hole drifting through interstellar space, found by how it affected background starlight and by estimating its mass. And then there's receipt number 3, Spacetime itself rigging. In 2015, we entered a new era, gravitational wave astronomy. When black holes merge, they send ripples through space-time, like a bell ringing in the fabric of reality. The Gravitational Wave Transient Catalog GWTC-3 contains 90 probable gravitational wave events, and by late 2025, LIGO Virgo Cagra reported that the first segment of their fourth observing run produced 128 significant events in the GWTC 4.0 update. So when someone asks, how many black holes have we discovered? The honest answer is, in our galaxy via traditional electromagnetic methods, fewer than 100 stellar mass black holes are well established, known today, depending on catalog criteria. Via gravitational waves, the catalogs now contain dozens to hundreds of merger events, many involving black holes, and they keep climbing with each observing run. In the universe overall, we believe there are enormous populations. For the Milky Way alone, estimates reach 100 million. That's the ledger idea. We don't see them. We balance the books using light, motion, and space-time ripples. Now let's get to the fun part. What are the verified, mind-bending facts that make black holes the strangest objects we've ever studied? Number 1. We have photographed black holes. Twice. Not a photo of the black hole's surface, but an image of the bright ring of matter around the event horizon. The Event Horizon Telescope released the first image of Sagittarius A star on May 12, 2022. And earlier, they imaged M87 star, the first ever black hole image, via the same global telescope network, often discussed alongside SGR A star in official EHT resources. That ring is basically light bending around gravity so hard it forms a glowing circle. The difference between M87 star and Sagittarius A star black holes is M87 star is way bigger, so things around it move more slowly. Sagittarius A star changes really fast. Material orbits it in minutes, which makes it harder to get a clear picture over long exposures. Number 2. Most big galaxies likely have supermassive black holes. A major 2025 NASA Chandra release concluded that more than 90% of massive galaxies, including Milky Way mass galaxies, contain supermassive black holes. So black holes aren't rare monsters. Number 3. Black holes can announce themselves by eating stars. When a star gets too close, it can be torn apart in a tidal disruption event, producing extreme bursts of light. Recent reporting in 2025 highlights how these events can produce unusually bright transients and help explain strange cosmic explosions. Number 4. The mass gap mystery is real. There's a predicted range where black holes are hard to form through normal stellar collapse, and yet gravitational wave observations keep finding mergers that strain our models, pushing scientists to rethink how some black holes grow, often through mergers. So black holes aren't just weird objects, they're active experiments, nature continuously showing us where our theories are strong and where they crack. Now the last big question. If black holes hide, collide, and consume, what is their role in the universe? Here is the biggest misconception. People think black holes only destroy, but in galaxy evolution, black holes often act like regulators. We are going to discuss 3 major roles that black hole plays in the cosmic system. Black hole role. Number 1. They shape galaxies through feedback. When a supermassive black hole feeds, it can launch jets and radiation that heat gas and influence star formation, basically controlling whether a galaxy becomes a star factory or goes quiet. This is why the question, does every galaxy have a black hole, matters, and why surveys using X-rays are so important for understanding which galaxies host them. Black hole role number 2, they are gravity anchors at galactic centers. We're increasingly confident that many large galaxies are organized around central black holes, and NASA summarizes this plainly when discussing black hole basics and Sagittarius A star. Black hole role number 3. They are the universe's collision record. Gravitational waves are like cosmic receipts stamped into space-time. Each new catalog entry is not just another detection. It's data about how stars lived and died, how dense star clusters behave, how black holes grow, whether Einstein's gravity holds up under extremes, and the pace is accelerating. The O4 observing run has already delivered hundreds of candidates and 128 significant events in its first analyzed segment alone. So black holes aren't just objects, they are tools to map invisible populations, to test physics at the edge of reality, and to explain how galaxies become what they are. Black holes are proof that the universe doesn't only build with light, it builds with gravity, with absence, with things you can't hold but can still measure. And that's the story of black holes. We didn't conquer darkness by seeing into it. We did it by noticing what the darkness does. It pulls, it bends, it rings. And every time we catch one, through X-rays, orbits, or space-time ripples, we're not just finding an object. We're reading another line in the universe's hidden ledger. If you enjoyed this episode, hit like. It helps the algorithm carry Fragile Universe further into the cosmos. And subscribe if you want more science mysteries told like stories, with sources you can verify. Because out here, the most important things are often the things you can't see.